And today I'm going to deliver a new concept that is about an syntax directed translation. And before learning about what the syntax directed translation is and knowing what the concepts that are included under the syntax directed translation, first I need to brief out by introducing what the semantic analysis is, and then I will enter into the concept that is a syntax directed translation. And as we know how an input string is syntactically checked by the syntax analyzers, right? And now we should know how to analyze the input semantically. And in semantic analysis, compiler analyzes the meaning of the program, and beyond the syntax analysis, program constructs are analyzed here. That means extra syntactic rules are imposed in this phase. And here the semantic analysis is carried out by scanning the input text, and it is static in nature. Make a note of that, it is static in nature. When we are performing a semantic analysis, whatever the text, whatever the input text that we are scanning, and the nature of that text should be in an static, it should not be in an dynamic. And the properties that cannot be captured by the context free grammars are captured by the semantic rules. So the properties could be of a name or scope analysis or type checking and type conversions, and all those comes under the properties. In this phase we will focus on type checking and type conversions, and but I will discuss this on later part. And now I will discuss on the syntax directed translations. And what a syntax directed translation is, just by giving an example here. In a function call we want the number of actual parameters to be same as the number of formal parameters. That means the actual parameters and the formal parameters should be the same. See, here we're having a language where L is equal to, in the slide there is a language, all of you see in the slide, we're having an example like L is equal to a power I, b power I, c power j, d power j, where I is having a condition that is greater than or equal to 1, and j is having a condition that is greater than or equal to 1. And here in a function call we want the number of actual parameters to be same as an formal parameters, where in this example a and b represents the actual parameters and c and d represents the formal parameters. What it means is the total number of I is equal to the total number of j. That means I and j are same here. But what it means, in compilation process based on certain features, we construct the syntax of the language. Clearly from the above example, it is not a context free language. And here the syntax analysis is not sufficient for the language to get compiled. So, what we are doing for that? We need something more than the syntax analysis. We already constructed some parsing techniques under the syntax analyzers, right? But we need something more than the syntax analysis. So, therefore, semantic analysis is done to handle the issues that are beyond the syntactic definitions. So that's the reason that we are learning the concept like in syntax directed translations, right? And in this we will learn how to do the static analysis using syntax directed definitions, and also discuss how attributes are associated with the terminals and non-terminal symbols of the grammar. And then we are learning how the evaluation takes place, right? And coming to the slides, and what the syntax directed translation is, what it refers to, it refers to a method. What method it is? A compiler implementation where the source language translation is completely driven by the parsers. What it means is, after generating the parse trees, that means after generating the corresponding parse trees from the constructed parsing tables, what it means is, we already constructed or implemented some type of techniques. From that techniques, what we generated a corresponding parse tree, based on which we generated the corresponding parse tree based on the constructed parsing table, right? So here what we are doing, we are performing the translations for that. We are performing the translations for the context free grammars, right? And the uh, point, the most basic point here, point number 1, it defines that it is a method, refers to a method of the compiler implementation where the source language translation is completely driven by the parsers. And here the parsing process and the parse trees are used to direct semantic analysis and translations of the source program. And also we are using an argument grammar here. With the information of the argument grammar, we are controlling the semantic analysis and the translations. And such type of an augmented grammar we are calling here, it is an attribute grammar. The name attribute plays an major role in the part of the syntax directed translations. Make a note of this. And then it is associated the associate attributes with each grammar symbols that describes its properties. First, initially we need to know what the attribute is. In previous slide, there we're having an augmented grammar. uh, we name it as an attribute grammar. What the attribute is, what always we're calling it as an attributes and attributes. Attributes can be a string or can be a number, or it may be a type, or it may be any memory location, or anything else that we can consider in the form of the attributes, right? And here the it associates, the syntax directed translations are associates with the attributes. That means from the grammar symbols we are describing its properties. Make a note of this. And attribute has a name and an associated value. With this we are defining which attribute it is, with the name and the and an associated value. In further, while learning the concept of syntax directed translation, we are defining which attribute it is. And with each production in a grammar, it gives them semantic rules or actions. That means the grammar consisting of a set of production rules. Every rule is in the form of an a tends to alpha. That means it consisting of two sides. One is on left hand side and another one is on right hand side. Based on the rule of the right hand side, we are performing some action. We are implementing some action, and we are calling that action, or we are calling that rule as in semantic rules here. And the general approach to syntax data translation is to construct and parse trees or the syntaxes. Make a note of this. There is a difference between the constructing of an parse tree and a syntax tree. I will explain in previous slides how to represent an parse tree and how to represent an syntax tree. Right? There is a difference while we are constructing the parse tree and the syntax tree. And there are some do's to be followed. So by following those do's, we need to construct these parse trees and we need to construct the syntax tree. Both the parse tree and the syntax tree are not same. The representation of the parse tree and the syntax trees are not same here. Make a note of this. Construct a parse tree or syntax tree and compute the values of attributes at the nodes of the tree by visiting them in some order. In which order we are visiting, and what is the need to visit the nodes, and how to compute the values for the nodes. And for these questions, for these such type of questions, we are having an answer in further slides. And here the syntax data translation to represent the semantic rules. These semantic rules are associated with the grammar symbols. Always the semantic rules should associated with the grammar symbols. That means the production rules. And to represent a semantic rules, we are having two ways of representations. One is an syntax directed definition, and the second one is an syntax directed translation schema. These are the two ways of representing the semantic rules which are associated with the grammar symbols. And now I am explaining what the syntax directed definition is. From the translation, from the SDT, by knowing the brief introduction about the SDT, that is in translation. Now we are learning SDD, that is an directed definition. What it means is, from the translations we are not directly representing the semantic rules. Here we are following some ways. Here we are implementing some ways. We need to follow some ways. What the types of ways are? Here we are having two types of ways. One is an syntax directed definition and the second one is an syntax directed translation schema. And while coming to the first one, that is a syntax directed definition, before knowing about what the definition of the syntax directed is, that is, and what is the SDD is, and just I'm giving a brief introduction about what the SDD is. And while doing the static analysis here, always we need to mention that we are implementing the semantic rules in an static in an static nature. That means we are not implementing in a dynamic nature. It should be an static. Make a note of this. It should be an static. And before knowing the definition of the what SDD is, first I'm briefing out the most important points about an syntax directed definition. And point number one is, while doing the static analysis of the language, we use syntax directed definition. Make a note of this. While doing the static analysis of the language, we use syntax directed definition. That means an augmented context free grammar is generated here with an implementation of an syntax directed definition. And in other words, we also can define it as in the set of attributes. Again, the word attribute we are repeating here. The set of attributes are associated with each terminal and non-terminal symbols. Set of attributes are associated with each terminal and non-terminal symbols. Again, what the attribute means, same. Wherever we get the word like an attribute, attributes defines the same things. It may be a string or a number or a type or a memory location or anything else. We are considering them as an attributes, right? And this syntax directed definition is a kind of an abstract specification. And why we are saying that it is a kind of abstract specification means, this directed definition is having an conceptual view of syntax directed translation. What it means is, it consisting of 4 steps. And initially, the first step number 1 is an input string, and step number 2 is an syntax tree, step number 3 is an dependency graph, and step number 4 is an evaluation order for the semantic rules. What it means is, by following these 4 steps, we need to implement one by one. We need to know one by one what the input string is, and what the syntax tree is, and what the dependency graph is, and what the evaluation order for the semantic rules is. We are in further and further classes, we are going to learn an individual concept like what syntax analysis and the representation of the syntax analysis, what is a dependency graph, and representation of the dependency graph with an example by taking in context free grammar. And for the syntax analysis also, for the syntax tree also, we are taking the example in the form of an context free grammar. And finally, for the context free grammar, for the semantic rules, we are defining the evaluation order. We are defining the evaluation order. These are the 4 main steps that the syntax directed translation consisting of. So we are calling them as a conceptual view of syntax directed translation in syntax directed definition. And here what it means is, firstly we parse the input token. Firstly we should parse the input token stream, and a syntax tree is generated. After parsing the input string, and syntax tree is generated. That is an definition of an, or the role of an syntax analyzer, as we all know that. And then the tree is being traversed for evaluation of the semantic rules at the parse tree nodes. So that means here with the translations, with in this concept here, what we are implementing here, what we are implementing is, we are implementing the evaluations for the semantic rules. We are implementing the evaluations. That means the tree, whatever the parse that we generated by taking an input string, and the tree is being traversed for evaluation the semantic rules at the parse tree nodes. And the implementation of this syntax directed translation need not have to follow all the 4 steps. Make a note. Follow need not have to follow all the 4 steps. In single pass implementation, we can write the semantic rules for the production. Right, in single pass implementation, the semantic rules can be evaluated during the parsing without explicitly constructing a parse tree or a dependency graph. What it means is, where as per the conceptual view, we are having 4 steps, right? The first one is an input string, the second is a syntax tree, and the third one is an dependency, and the fourth one is an evaluation order. And here what I am saying here is, in single pass implementation, the semantic rules can be evaluated during the parsing without constructing, or without constructing the parse tree or the syntax tree or any type of an dependency graph for the grammar. Make a note of this. In such semantic evaluation at the nodes of the syntax tree, values of attributes are defined for the given input string. How the values of the attributes are defined? See, all of you see the slide that I shared to you all. Here we are having an example is a production from the grammar. I am taking this production. Now I am implementing the semantic rule for this production. Only for the for this production I'm implementing the semantic rule. What it means is, here I define the value of the attributes. I define the value of the attributes for the given input string. My input string is e tends to e1 plus t. At the time of implementing the semantic rules, that means at the time of implementing the semantic rules, during the parsing, without constructing and parse tree, or without constructing a dependency graph, here see, directly I write the rules, I implement the semantic rule here without any parse tree or syntax tree, or without any construction of the dependency graph. Directly I parse the semantic rule here. What it means is, here the values of the attributes are defined for the given input string. Initially the input string consisting of the variables. That means here we're calling them as a nodes. It may be in terminal or non-terminal. Here we're calling them as a nodes. And the production consisting of a nodes. And here I am without any values, from the given grammar, we're having the production. After performing or after implementing the semantic rule for this production, my nodes consisting of, that means the values of the attributes are defined for the nodes, for the given input string. Is it clear? That means e dot code is equal to e1 dot code, or we're having the two nodes here. It may be e1 or t, and the operator is in place. In such a way, we need to implement the semantic rules for each and every production from the given grammar. Right? Is it? I think you all understand how to implement a semantic rule from the given production. Here, where there are no logics to be implemented, no algorithms to be followed, or no more syntaxes are there to be followed here. Just what we are doing here is, we are defining the values of the attributes. We're defining the values of the attributes, or values of the nodes. How we're defining the values of these? How we're defining the values of these? The attribute can be a string, the attribute can be an value, the attribute can be a number, the attribute can be an any type of a data type, either it may be a memory location, whatever it may be. I defined an attribute here. I defined an attribute here. That means the values of the attributes are defined for each and every node in the production rule. Right? Is it clear now? And this is nothing but an syntax directed definition. Syntax directed definition. And such a parse tree containing the values of the attributes at each node. If the tree consisting of, make a note of this. Now I just explained with a rule. When I am implementing in the tree structure, when I implement this rule in a tree structure, then how I am calling the tree as, how I am naming that tree as. A parse tree containing the values of the attributes at each node is called as an annotated or decorated the parse tree. Make a note of this here. The two terms I am using, annotated or decorated. Either it may be an annotated or either it may be a decorated. We can use any one of these. And the definition of what the annotated parse tree or the decorated parse tree is, parse tree containing the values of the attributes. Make a note. Parse trees containing the values of attributes at each node is called an annotated or decorated. And now coming to the definition of the syntax directed definition. Now coming to what the definition of this is. And this syntax directed definition is in context free grammar together with attributes and the rules. Together we are implementing the both attributes and the rules at the syntax directed definitions. What it means is, attributes are associated with the grammar symbols and rules are associated with the productions. Make a note. Here I am taking an example. Attributes are associated with the grammar symbols and rules are associated with the productions. What it mean? The left hand side part and the right hand side part. And the RHS is associated with the rules, are associated with the productions, and the left hand side LHS are associated with the grammar symbols. That means attributes are associated with the grammar symbols. Make a note of this, which are the, in the production rule, which are the grammar symbols and which are the productions, and attributes are associated with what and the rules are associated with what in the given production from the grammar. Make a note of this. And here I'm defining this syntax directed definition as, It is a generalization of a context-free grammar. I know what the definition of the context-free grammar is, right? G is equal to VTPS. And here how I am defining this SDD is, it is a generalization of the context-free grammar. Why? In, in which each grammar production is associated with a set of semantic rules. Each grammar production, whatever the production that I am having from the grammar, and each grammar production is associated with a set of semantic rules. And here we need to follow some syntax. Following some syntax means here we are not implementing or we are not constructing like that. What it means is, and in further I need to know what type of the attributes I am having here. So, and while defining the definition of the syntax directed definition, there itself I need to define some function like some form like this, that is, and some syntax. What it means is, again I'm repeating that what the SDD is a generalization of the context free grammar in which each grammar production is associated with a set of semantic rules of the form. What the form is, it should be like a is equal to f of b1 comma b2 comma so on bn. A is equal to f of b1 comma b2 so on bn. What it means is, here a is an attribute in this function. A is an attribute in this function. That means a is an attribute that should obtained from the function. By implementing this function, I need to get the value here. That means after computing this function, the value is obtained. That value is assigned to an a. And now what the a is an attribute. A is an attribute. Make a note of this. A is an attribute. Make a note of this form. A is equal to f of b1 comma b2 comma so on. And a is an attribute. And here the function is nothing but a computation of some values, computing some values. And whatever the computed value that we get here, that is assigned to the attribute. And now I need to define which type of an attribute it is. I need to define which type of an attribute it is. And so for that question, I am having two types of an attributes. The first attribute is an inherited attribute and the second attribute is an synthesized attribute. Make a note of this. First one is an inherited. These inherited attributes can also be called as an capital L attributes, capital L attributes. And the synthesized, the second one is an synthesized attributes, that is an S attribute. Synthesized attributes can be called as an S attributes and inherited attributes can be called as an L attributes. And what an inherited attribute is, what is the definition of inherited attribute is? Now all of you make a note of the definition. It is most important because in further and further the remaining concepts are based on these types of attributes. Based on the definition of these types of attributes, we are implementing the functionality of the semantic rules. We are implementing the functionality of the semantic rules for the given grammar, right? So if you know what the definition of inherited attributes and what we need to consider under the inherited attributes, then it is easy to represent the trees. It is easy to represent an trees. And what the definition of the inherited attributes is, see, I am defining an inherited attribute for the value a, that is for the attribute a. For the attribute a. A is an inherited attribute now. A is an inherited attribute. And the value of a is computed from the values of the attributes at the siblings and the parent of that node. Is it clear now? Siblings are nothing but an brother and sister relations. Siblings are nothing but an brother and sister relations. For example, how many siblings are you? Means is there any other more, or you only the one doctor to your parent, like that? Is it clear? Siblings means brother and sister relations, or sister and sister relation, or brother and brother relation, whatever it may be, we are calling that relation as in siblings. And here again I'm repeating how I am getting an value for the a. Means a is an inherited attribute. Now I'm computing the value for the a now. And how I am computing the value for the a means based on the values of the attributes at the siblings and the parent of that node, right? And in another way, how I am defining this means, value of the inherited attribute at a node in a parse tree is defined using the attribute values at parent or siblings. Is it clear? That means I am taking the values from the parent, or I am taking the values from the siblings, or from the siblings to the parent and that parent to the inherited attribute. Is it clear now? Is it clear? Either we can take only from the siblings, or either we can take only from the parent. But here, in inherited attributes, what to compute and value for value a for the inherited attribute, I need an values for the attributes of these siblings along with an parent, of that node, not for another node of that node. Make a note of this. And this is the definition of an inherited attribute, and this I will explain with an example in further slides. First, you all know what the definition of inherited attributes is. And now it is a synthesized attribute. Synthesized attribute can also be called as an S attribute, right? S attribute. And how we define this synthesized attribute? What is the definition of synthesized attribute means? Value of synthesized attribute at a node in a parse tree is defined using the attribute values at the childrens of that node in the parse tree. Is it clear? Again, I'm repeating how the synthesized attribute is computed means, based on the attribute values of the childrens of that node, not for another node, of that node in the parse tree. That means only I'm considering the child nodes here. Only I'm considering the attribute values of the child nodes here. But in inherited, I'm considering both the siblings and the parent node. Siblings and the parent attributes of that node, I'm considering that as an value for the inherited attribute. And here I'm considering only the child node of that node, child attribute, not a node, child attribute of that node, values of the child attributes of that node is considered for the synthesized attribute, right? To compute and synthesized attribute, here only I am taking the child nodes, values of the child nodes. But in inherited, I am taking the both siblings and the parent nodes. Make a note. That's the difference between the inherited and the synthesized. Inherited can be represented as an capital L attributes, and synthesized it can be represented as an S attributes, right? And these are the two types of an attributes here. Two types of an attributes in syntax directed definition. And here, what the next one is, evaluating an syntax directed definition at the nodes of a parse tree. What it means is, in further we are going to know how the evaluation process takes place. And a parse tree showing the values of its attributes is called an annotated parse tree. As I already explained what the definition of an annotated or decorated parse tree is. And with the synthesized attributes, we are evaluating the attributes in an bottom-up order. That means here we are implementing an bottom-up approach, that is from leaves to root. And this process, this evaluation process, I will explain in further classes. But here, what the thing we need to know, what the thing that we need to know is how to represent an annotated parse tree. How to represent an annotated parse tree, or it can also be called as a decorated parse tree. See, here we're having an example. Construct the annotated parse tree for the expression 3 into 5 plus 4n. This is the question. Construct the annotated parse tree for the expression 3 into 5 plus 4n. And this we are taking from the given grammar. Here we're having a grammar. We're considering this grammar from these productions. Right? From these productions, we represent the grammar. Sorry, we represent the parse tree. From the grammar of those productions, here we represent an annotated parse tree. Why we are calling it as an annotated parse tree? Why we are calling it as an annotated parse tree? See, the parse tree containing the values of attributes every node consisting of an values along with an attribute. Along with an attribute there are values, right? So values of attributes at each node is called as an annotated or decorated. If this tree structure does not consisting of the attributes and the values, means it represents just an parse tree structure. The name of that structure is an just it is an parse tree. But here the tree consisting of both the attribute for the node along with an value. That means the attribute is associated with an value, right? Attribute is associated with an value. That means each node, the values of attributes at each node is called as an annotated parse tree or decorated parse tree. Is it clear now how to represent an annotated parse tree? And from the given grammar, see here at the synthesized attributes we are having the grammar, and for each and every production rule there itself we define the semantic rules. Here we define the semantic rules for this. What it mean? Here we perform the semantic evaluation at the nodes of at the nodes, and the values of the attributes are defined. Values of the attributes are defined. Why I gave dot val here, why I use an dot val here? Because when I'm using the grammar to generate the language, by using this grammar I need to generate the language. What my language is consisting of set of strings, and when I'm checking out to generate the set of strings, and by using these production rules, finally in every input string I'm having an digit. In every input string I'm having a digit. What it means is it generates an number. It is generating a number. But that means if I use any value, then I can easily compute it. Then I can easily perform the computations between the nodes. So I am using an attribute like an val here. Val is an attribute as a type of an attribute. Dot val with val is an attribute. With this attribute I am defining the nodes. I am defining with the nodes l dot val, e dot val, and I am defining these with an nodes. Values of the attributes are defined here, right? And for the given production rules from the grammar, and with this semantic evaluation, I am performing or I am representing an annotated parse tree for the expression 3 into 5 plus 4n. What it mean? From the given grammar, my root node is, my starting symbol of the given grammar is an L. That means L tends to, L is the root node of the given grammar. L is the label starting node. So L tends to En. N is not, N is an constant number. So N is, for N we are not giving any attribute value. We are not defining the attribute for the N because it is a constant. So only we are defining for the E. E is a node here, right? And these two are the nodes, and this is a node, and again these two are the nodes. So for every node we are defining the attributes, defining the attribute. And finally it is a digit is nothing but, digit is an lex val. That means here we need to substitute, we need to insert any number, then we will perform the computations, and that computation value is associated with the children nodes, and it is associated with the parent nodes, and finally it is associated with the root node. And see L dot val, and initially I need to compute 3 into 5 plus 4n from the given grammar, and here I am using the semantic evaluation rules. Already the rules are evaluated there. So by using those rules I am performing this tree structure. I am implementing this parse tree structure, and what I need, 3 into 5 plus 4n, n is a constant number. So choosing an appropriate rules along with an attributes, that means choosing an appropriate nodes along with the attributes, and just giving a value for that node and perform the computation. That computation value is assigned to the parent node, and again this is a child node to the e dot val, right? So this value is assigned to the parent of this e dot val, and here we performed some computation, 15 plus 4, and after performing this 15 plus 4 we get a 19, and this from the children the value is associated with the parent, right? After computing whatever the values that are computed from the children that are associated with the parent node. So here e dot val is an parent node. So after computing the child nodes, we get an value. That value is associated with an parent node, and this value, this is an child node to the L dot val. Why? Because L dot val is an parent node, because that's the root node for the given grammar, for the given semantic rules, evaluated semantic rules, or from the given grammar or from the production rules. L is an starting symbol of the given grammar, so it acts, this node acts as an root node of the tree. So finally the parent is an L dot val, the parent is an L dot val, and this value E dot val value is associated with the parent node L dot val. Val is an attribute here, right? Nodes are associated with the attributes along with the values. This is the parse tree structure by using the evaluated semantic rules. I think is it clear how to represent and parse trees for the expressions like 3 into 5 plus 4n. And now for the next class, please make a note of this question. You annotated parse trees for the following expression. You annotated parse trees for the following expression. Please all of you make a note of this question and draw the annotated parse trees for the given expression. The grammar is same. This from the grammar L tends to En. That means you need to take the evaluated semantic rules, and from this evaluated semantic rules you need to draw the structure, that is a tree representation. First initially write down this grammar, and from this grammar note down the semantic rules. And then for the questions 3 plus 4 into, don't eliminate this open parenthesis and closed parenthesis. You should use this. Don't eliminate this. Don't remove these braces. These are all from the given production rules. See here, we're having a rule like F tends to open parenthesis, E closed parenthesis. So you need to use this rule. You need to use this rule, and then you need to parse the tree and finally get the output computed value for this expression. Note down these 3 expressions. And in this class I just introduce what the syntax directed translation is, and after introducing and after briefing out what the syntax directed translation, and then I explained you what the types of what it means to define the semantic rules. We need to represent in 2 ways. We are having 2 ways to represent the semantic rules. In those 2 ways, we are having the first way is an syntax directed definition. So up to now we learn only what the syntax directed definition is and what type of an attributes that the syntax directed definition consisting of, and how to represent an annotated parse tree, right? And with by giving an expression, if you are having a question like that, construct the annotated parse tree for the following expressions. You should represent in this way. That means the tree, whatever the parse tree that you represented, the tree should be associated with the attributes along with the values. Then only it can be called it as an annotated parse tree, right? And from the introduction of the syntax directed translation, and then I explained you what the syntax directed definition is, and there I briefing out the introduction about the syntax directed definition. Then I explained in detail about the syntax directed definition. And here in syntax directed translation we are having 4 steps. That means the conceptual view consisting of 4 steps. The first one is an input string, the second one is a syntax tree, third one is a dependency graph, and the fourth one is an evaluation order for the semantic rules. That means in this syntax directed definition, we need to learn one by one step now. For in further next further classes, I will explain what the syntax tree is and how to represent the syntax trees, and what the dependency graph is and how to represent the dependency graph, and what the evolution order for the semantic rules is, how to represent the evolution order for the semantic rules. And after completing these 4 steps, the overall concept of syntax directed definition will be completed, right? And then we will learn the next type, that is an syntax directed translation schema, because for representing the semantic rules we are having 2 ways of representation, one in a syntax directed definition and the second in a syntax directed translation schema. Before going to learn about how what the implementation of the translation schema is, we need to know how the syntax tree is represented and how the dependency graph is represented, all from the given context free grammars. Here we are considering the specification should be in the form of a context free grammars, right? And then finally how the evaluation order takes place from the given productions in the given grammar. And after completing these steps, then we will enter into the second way of representing the semantic rules, that is syntax directed translation schema.